In this example of using Lisp, we have two sets of classes. One set of ducks with a base class duck being inherited by MalaDuck, RedDuck and RubberDuck. So the subclasses don't define anything particular. They all share the name attribute of the base class. In another set of classes, we define flying behavior. So this example is taken from the Head First Design Patterns book, where fly behavior is separated from a hierarchy of classes because maybe we want other flying behavior for rubber ducks than other ducks. And also we want to illustrate there that we can define new behavior separate from new classes of ducks and still have some standard type behavior of how ducks behave when they fly. Using Lisp type methods, we describe a generic method fly so that it has a number of specific implementations for MalaDucks and RubberDucks. MalaDucks can fly with wings, and if RubberDucks are supplied with the behavior flying with wings, then we simply write that RubberDuck something is flying with wings. So this definition of a generic method allows us to select the concrete fly method we want to use at runtime, depending on both the first argument, which can be any type of duck, and the second argument, which can be any type of fly behavior. So using this example, we supply a fly behavior, fly with wings, and a duck, rubber duck. Now, we select based on both the type of duck and the type of fly behavior, the correct method. Then it's of course possible that we select a set of ducks and fly behaviors for which there is no applicable method. Which is okay, we can add default definitions if we want. So for the general class duck and general class fly behavior, we can say that this is the default fly behavior, like so. But the specific yes, so now there is no combination of MalaDuck and no fly defined here. But we could imagine that we create our own no fly standard behavior. Which would be a more specific method than this, which is defined for the general fly behavior. So let's see which one will be used. Now we select the default no fly behavior method instead of the default fly behavior method. And if we specifically add a method for MalaDucks and fly behaviors and try again, we get the default fly behavior for MalaDucks. So we can specialize on all parameters to a method. Specialize on the first, specialize on the second, and the most specific, based on all types of runtime types of arguments, will be selected. So this is due to Lisp's ability to do multiple dispatch. That is, at runtime, dispatch on the types, runtime types of all arguments in a method invocation. And because Lisp allows us to define methods outside of classes like this, we can also add new behavior as we go along without having to resort to visitor type implementations, where the class structure, that is our behaviors and our ducks, has to implement accept methods, and our visitors will have to have implementations for all concrete types of fly behaviors. So using Lisp's ability to do multiple dispatch, we can define behavior in a different way, separate from our class structure.